Welcome back. We are solving problems on problems in applied thermodynamics. BME 401, 18 ME 42, 17 ME 43, 21 ME 52, and then 15 ME 43. So we will take up a problem on air standard cycles. So we have solved in the previous sessions the problems on one problem on Otto cycle, followed by a problem on a diesel cycle, and then we have gone into one derivation on Otto cycle. In today's session we will take up a problem on dual combustion cycle, or which is called as semi diesel cycle or limited pressure cycle. The problem goes in this way, that is, in an air standard limited pressure cycle has a compression ratio of 15 and compression begins at 0.1 megapascal 40 degrees centigrade. The maximum pressure is limited to 6 megapascal and heat added is 1.675 megajoules per kg. Compute heat supplied at constant pressure per kg of air, heat supplied at constant volume per kg of air, work done per kg of air, cycle efficiency, cutoff ratio, and mean effective pressure. As I said, this problem is on dual combustion cycle, or what you call it as limited pressure cycle. So now with this problem, let us write what are the data given in the problem first. So he has given us the value of compression ratio, that is RC equal to 15. What is RC? RC is nothing but V1 by V2, or it is P2 by P1. Then pressure P1 is given to us. P1 is 0.1 megapascal. That is, he says in the problem that the compression ratio is 15 and the compression begins at 0.1 megapascal and the temperature given to us is 40 degrees. So T1 equal to 40 degrees centigrade. So let us convert this into Kelvin. So 40 degrees centigrade will be, adding 273, it becomes 313 degrees Kelvin. Then next, the maximum pressure is limited to 6 megapascal. So it is P3 and P4 given in the problem, that is 6 megapascal. Then along with that, the heat is added at 6.75 megajoules per kg. So QS, total heat added, QS is equal to 1.675 megajoules per kg. What you have to find out? You have to find out heat supplied at constant volume, that is, you have to find out QS1, QS2, heat supplied at constant pressure. Then next you have to find out W net, followed by efficiency, cycle efficiency, then cutoff ratio, rho, and you have to find out MEP. These are the things what we need to find in the problem. So you need to find out heat supplied at constant volume, heat supplied at constant pressure, work done per kg of air, thermal efficiency, cutoff ratio, and mean effective pressure. Now let us take the PV diagram and TS diagram. So heat is supplied 1 to 2 isentropic compression in the compressor, then followed by constant volume heat addition from 2 to 3, and then constant pressure heat addition, that is from 3 to 4, and then 4 to 5 again isentropic expansion, and then 5 to 1 heat rejection at constant volume. This is what is the PV diagram. So 1 to 2 work of compression, then work of expansion, or we write it as WT, right? 4 to 5, then 2 to 3 and 3 to 4 are the two processes where heat are added, that is QS1 and QS2, and 5 to 1 heat rejection. So if you see the TS diagram, I'll just show you the TS diagram now, right? 1 to 2 isentropic compression, 2 to 3 constant volume heat addition where temperature there is rise in temperature, then 3 to 4 again constant pressure heat addition, and then 4 to 5 again isentropic expansion, and 5 to 1 constant volume heat rejection. So 1 to 2 and 4 to 5 both are isentropic processes. One is compression, that is 1 to 2 is compression, and 4 to 5 is expansion. Therefore entropy remains constant during these two processes. Now with this given data, let us start solving the problem. So we will take up during the process 1 to 2. So I'll just go to the PV diagram or TS diagram, the process 1 to 2. So during the isentropic compression process 1 to 2. So let us write. So during isentropic compression process 1 to 2, what is happening? What is T2 equal to? T2 will be equal to, or T2 by T1 will be equal to RC to the power gamma minus 1. RC is given to us. So I want the value of T2. T2 will be equal to T1 into bracket RC to the power gamma minus 1. So let us substitute those values. So the value of T1 is given is 313 degrees Kelvin. RC is 15. So gamma is 1.4 minus 1. That is, we will get the answer to be equal to, the temperature T2 will be equal to 924.65 degrees Kelvin. This is the value of T2. So T2 will be equal to T1 into RC to the power gamma minus 1. Now, with the value of T2 known to us, let us find out again next P2. So P2 will be equal to P1 into RC to the power gamma. The only thing that is required in this chapter is to know the PVT relationships and the PV and TS diagram of various processes. That is PV and TS diagram of the cycles. So the pressure P1 is given 0.1 megapascal, RC is 15 and gamma is 1.4. So calculate the value of P2. You will get it as 4431.26 kilopascal. This is the value of P2. So after obtaining the value of P2, let us find out expansion ratio. Expansion ratio, or it is called as pressure ratio, alpha equal to P3 by P2. So in the problem, P3 is given to us. So it is 6. So it becomes 6000 kilopascal divided by 4431.26. So which will fetch me the value of alpha as 1.35. So upon calculating the value of alpha, now let us take the next process, that is constant volume heat addition process. I'll just again get back into the PV and TS diagram, that is during the process 2 to 3. You can see this process 2 to 3, which is a constant volume heat addition process. Let us write the PVT relationships and find out the value of T3. We will find out this value of T3 now. So during constant volume heat addition process what is it? 2 to 3. The process is 2 to 3. So I'll write the PVT relationships. P2 V2 by T2 will be equal to P3 V3 by T3. So if I write this relationship, P2 V2 by T2 is equal to P3 V3 by T3, we know that the heat is added at constant volume. So V2 will be equal to V3. So therefore the equation gets modified as P2 by T2 will be equal to P3 by T3. That is T3 by T2 will be equal to P3 by P2. I repeat, T3 will go to the numerator. I just show you. T3 will go to the numerator. T3 by T2. T2 will remain in the denominator as it is. P2 is transferred to the next side, that is in the denominator, P3 by P2. What is P3 by P2? P3 by P2 is just now we have found out it is expansion ratio or pressure ratio alpha. So T3 will be equal to, it is T2 into alpha. I repeat, T3 will be equal to T2 into alpha. T2 is known to us, just now we have obtained the value. It is 924.65 into alpha is 1.35. So substitute these two values, get the value of T3. So T3 will be equal to 1248.27 degrees Kelvin. This is the value of T3. Next, find out heat added at constant volume, which is asked in the problem. So heat added during constant volume process which is that constant volume process. I will write it again, 2 to 3. So heat added during constant volume process 2 to 3 is QS1 is equal to mCV T3 minus T2. So we are considering per unit mass. So M is 1. CV is known to us. It is 0.718. That is specific heat at constant volume of air into T3. Just now you have found out. It is 1248.27 minus T2 value, that is 924.65. So put these values, calculate, you will get the answer as QS1 is equal to 235.03 kilojoules per kg, because we are finding out per unit mass, that is per kg. Upon getting this value, next calculate the value of QS2. So we know that total heat added or heat supplied, QS is equal to QS1 plus QS2. So QS1 is given in the problem QS is given in the problem, and just now you have found out the value of QS. So you can find out the value of QS2. So QS2 will be equal to, that is heat added during constant pressure process. What is it? The constant pressure process in the PV diagram and TS diagram is 3 to 4. I repeat, it is 3 to 4. You can see even on the TS diagram it is 3 to 4. So I will write it as 3 to 4, which is given by QS2 is equal to, QS is known to us, QS minus QS1, that is 1675 minus 235.03, which just now we have calculated the value of QS1. So QS2 will be equal to 1439.97 kilojoules per kg. So upon calculating this value, right, next find out rho. That is, sorry, next find out the value of T4. Next, so I will find out the value of T4 by taking the equation of QS2, that is heat added during constant pressure process 3 to 4 is given by QS2 is equal to mCp T4 minus T3. So m is per unit mass, and you have got the value of QS2, it is 1439.97. Mass is 1, Cp you know it is 1.005, T4 minus T3 is 1248.27 degrees Kelvin. So calculate the value of T4. So T4 you get it as 2684.79 degrees Kelvin. So after getting the value of T4, find out cutoff ratio. So cutoff ratio rho is equal to T4 by T3, that is 2684.79 divided by T3, that is 1248.27. So you'll get the value of rho as 2.15. So upon getting the value of rho, next find out the value of T5, that is during isentropic expansion process 4 to 5. Again I will show you this with the help of a PV and TS diagram. You can see this during the isentropic expansion process 4 to 5, which is shown on the TS diagram now. So you can write the equation as T4 by T5 will be equal to V3 by V4, or sorry, will be equal to V5 by V4 whole raised to gamma minus 1. So I will now find out the value of V4 by V5. So V5 by V4, I repeat, V5 by V4 will be equal to, V5 is same as V1. So V1 into V3. I am multiplying, dividing by V3. So I will show this on a PV diagram now. Again, just see here. You can see what is the value of V5. V5 is same as V1. You can plot this, right, with a dotted line. V5 is same as V1. Similarly, I am just taking it down to show you. V2 is same as V3. Clear on a PV diagram. So I repeat, V2 is same as V3 and V5 is same as V1. So with this, I am substituting in the equation. So that is V5 will be equal to V1. I'll write here, since V5 is equal to V1 from PV diagram, substituting the value of V5 as V1 and multiplying and dividing by V3 and rearranging the terms. So V1 by V3 into V3 by V4. Now just see here, V3 will get cancelled. So I'll get V1 by V4. V1 is same as V5. So again you get back the same answer. So what is V1 by V3? Or I can write this, V3 is same as again V2. So V1 by V2 into V3 by V4. I will write again, V2 is same as V3. So what do I get? V1 by V2 is RC and V3 by V4 is 1 by rho. That is V4 by V3 is rho. So it is RC by rho. Repeat, it is RC by rho. So I can write T4 by T5. T4 by T5 will be equal to RC divided by rho whole raised to gamma minus 1. Now find out the value of T5. So T5 will be equal to T4, taking it on the other side, into rho by RC whole raised to gamma minus 1. So T5 will be equal to T4 into rho by RC to the power gamma minus 1. T4 value, you know, it is 2684.79 multiply by rho. Rho is 2.15 whole raised to 1.4 minus 1 divided by RC. RC is 15 whole raised to 1.4 minus 1. I am using theory of indices, that is rho to the power gamma minus 1 divided by RC to the power gamma minus 1. I have separated the terms. So therefore you will get the answer as T5 will be equal to 1232.08 degrees Kelvin. So after getting the value of T5, let us find out heat rejected. Heat rejected QR will be equal to mCv T5 minus T1. mCv T5 minus T1. M is 1 per unit mass. CV is 0.718. T5 just now you have calculated the value. It is 1232.08. T1 is given to us in the problem 313. So get the value of heat rejected. So heat rejected will be equal to 659.89 kilojoules per kg. So I have found out the value of QR, heat rejected. So next find out net work done. Net work done will be equal to work done, or which is called as W net. W net will be equal to, it is QS minus QR. So 1675 is given in the problem, minus heat rejected is 659.89. just above you have calculated it. So you'll get it as 1115.11 kilojoules per kg. Next, find out efficiency. So there are two equations to find out efficiency. Now first equation what I will use is, I will just use the equation of heat supplied minus heat rejected divided by heat supplied. I use the equation QS minus QR by QS, that is 1675 minus heat rejected is 659.89 divided by heat supplied is 1675. So multiply it by 100, or before that if you calculate you will get it as 0.6059, or it is 60.59%, or you can use the equation, that is, I will just give you that equation also. The equation for efficiency will be given by, efficiency will be equal to, that is air standard efficiency will be equal to 1 minus 1 by RC to the power gamma minus 1 into bracket alpha rho to the power gamma divided by rho to the power gamma minus 1 divided by alpha minus 1 plus alpha gamma into bracket rho minus 1. This is also equation you can use. So here you can substitute the values, that is 1 minus 1 by RC is 15 raised to 1.4 minus 1, and then we know the value of alpha. Alpha is 1.35 into rho value you have found out, it is 2.15 raised to 1.4 minus of 1 divided by alpha is 1.35 minus 1 plus alpha is 1.35, gamma is 1.4, into bracket rho is, you have found out the value of rho, it is 2.15 minus 1. So you will get the same answer, that is it is 0.66059, or it is if you multiply it by 100 it becomes 60.59%. So you can use any of the two equations to find out the value of efficiency. The last thing which we have to find out is mean effective pressure, that is MEP will be equal to, mean effective pressure MEP will be equal to, the equation is P1 RC to the power gamma into bracket alpha minus 1 plus gamma alpha into rho minus 1 plus RC to the power gamma minus 1, then gamma minus 1 into bracket you have you have alpha and then gamma raised to rho raised to gamma minus 1 divided by this whole term, divided by, or here you can divide this equation by RC minus 1 and here it is gamma minus 1. So substitute all the values, that is we will substitute all the values one by one. P is 100, so I have converted this into Newton per meter square. RC is 15 raised to 1.4, then 1.35 minus 1 plus gamma is 1.4, alpha is 1.35, rho is 2.15 minus 1 plus RC is again 15 raised to 1.4 minus 1, then into bracket alpha is 1.35, then rho is 2.15 whole raised to 1.4 minus of 1 divided by RC is 15 minus 1. This side you have in the denominator 1.4 minus 1. So this is the equation to find out the value of MEP, mean effective pressure. I have substituted all these values. Then let us calculate and find out the value of MEP. So you get the answer to be 2000.13 kilopascal. This is a value of MEP. So I'll just get back what all I have done, one by one. Just rewind the things. So I have written the first given data. After writing the given data, what I have done is I have drawn the PV and TS diagrams. This is a PV diagram followed by the TS diagram, and then I have taken individual processes. I have taken first the isentropic compression process 1 to 2 and I have found out the value of T2. After finding out the value of T2, next what I have done is I have found out the value of P2. You can see here. P2 will be equal to 4431.26. After finding out the value of P2, I have found out the expansion ratio. It is 1.35. Then I have taken the constant volume heat addition process 2 to 3 and then I have calculated the value of T3. Then found out the heat added at constant volume process 2 to 3 which is asked in the problem. Then I have calculated the value of QS2, that is heat added during constant pressure process. Just show you now. Heat added during the constant pressure process by subtracting the heat supplied given in the problem minus heat added during constant volume. Then found out the value of T4 by using the equation of QS2 heat added. during constant pressure process. Then found out cutoff ratio. Then found out the value of T5, just here, by using the isentropic expansion process 4 to 5. After calculating the value of T5, I have calculated the value of heat rejected QR, that is MCV T5 minus T1, because heat is rejected during constant volume process. Then found out the value of W net, QS minus QR. Then efficiency, QS minus QR by QS, or you can use air standard efficiency equation, 1 minus 1 by RC to the power gamma into bracket alpha rho to the power gamma minus 1 divided by alpha minus 1 in the bracket plus alpha gamma in the bracket rho minus 1. Using this equation, find out the value of thermal efficiency. After finding out the thermal efficiency, I have used the equation for MEP. The equation for MEP goes in this way: P1 RC to the power gamma in the bracket alpha minus 1 plus gamma alpha rho minus 1 in the bracket plus RC to the power gamma minus 1 in the bracket alpha rho to the power gamma minus 1 whole divided by RC minus 1, and in the first term denominator it is gamma minus 1. So substitute all these values in this equation and then calculate the value of mean effective pressure. We get the value of mean effective pressure to be equal to 2000.13 kilopascal. So in the next session, we'll take up few more problems. Thank you.